In this video, we're going to cover the naming and chemical formulas of simple binary ionic compounds. So remember, an ionic compound is one that consists of a metal and a nonmetal. And so we're just going to focus on the simple binary, or what that means is two-element type of chemical compounds, ionic compounds, and their naming systems. So let's first talk about the set of rules for going from the chemical name to the chemical formula. The first thing we're going to do is write the symbol for the metal. So we're going to go to the periodic table and find the symbol for the metal, and then we're going to follow that with the symbol for the non-metal. Once we've got that, we're going to write the valences or charges above each element, and I'm going to show you how to find those in just a minute. We're then going to crisscross down the numbers to just the numbers to the subscript position. And then we're going to reduce the formula and or remove any subscripts of 1. So before we get into some examples, we need to take a look at how do we come up with the valences or the charges for each of the elements. Well, we can get those simply from the periodic table. So for example, all of our group 1 elements all take on a charge of +1 because they lose 1 electron to have a full valence shell. So when something loses an electron, it gains a positive charge, and all of these in group 1 will lose 1 electron. So they are all going to have a +1. In group 2, these will have a +2. Group 3 will have a +3. We're going to skip group 4 for a second, and then group 5 is when the elements start gaining electrons. So these are going to gain 3 electrons. So when something gains electrons, it has a negative charge. So that'll be -3. Group 6 will all be -2. The halogens are -1. And then noble gases are 0 because they do not form charges. Now, I skipped this group 4 here, but that's because it depends on what it's combined with. It can either take a +4 or a -4, depending on whether it's combined with another metal or whether it's combined with another non-metal. So the nice thing about simple ionic compounds is that you're never going to run into that scenario, so you don't really need to worry about it with the examples we're showing in this video, but just know that they can take a +4 or a -4 valence depending on what else it is combined with. So now that we have that information, let's take a look at a few examples and how we come up with the chemical formulas. So let's start with magnesium chloride. We're going to look on our periodic table and find that magnesium is Mg, and then chloride means chlorine, so that is Cl. And using our periodic table, magnesium's a +2 and chlorine is a -1. So from here, we want to take those numbers and crisscross them down to the subscript position. So that's going to create Mg1 Cl2. And then we want to get rid of any 1s or reduce it down. So we're just going to get rid of that 1 there because it doesn't make sense to leave it in. So the formula for magnesium chloride then is MgCl2. Our next example, calcium oxide. Calcium is Ca, and oxide means oxygen, so that's an O. Calcium takes a +2. Oxygen takes a -2. We're going to crisscross those down, and that's going to become Ca2O2. But then they're both 2s, so we can reduce this down to CaO. So calcium oxide's formula is just CaO. And finally, the last example, aluminum sulfide. Aluminum's Al. Sulfide means sulfur, so that is an S. The aluminum is +3. The sulfur's -2. Let's crisscross those numbers down to the subscript position. So that's going to create Al2S3. And there's nothing to reduce here, so that is our final chemical formula. So that's great. That's how to come up with formulas. Now, how do we go back if we're given a formula and come up with a name? It's actually easier. So what we're going to do is take the formula. We're going to find the name of the metal. We're going to write that first, and then we're going to follow that by the non-metal's name. second, and then we're going to change the ending of the nonmetal to IDE. Let's take a look at some examples then. Our first example here, Na2O, if we look up Na on the periodic table, that is sodium. And then our second element is oxygen. But we're going to change the ending. We're going to get rid of that -gen part of it, and we're going to add on the ending IDE. So this becomes sodium oxide. For the next one, Ki, K is potassium. If we look that up on our periodic table, and then I is iodine, but we're going to get rid of the ending there, and that becomes iodide. So potassium iodide. And finally, our last example, Be3N2. Be, if we look that up, is beryllium. And then N is nitrogen. So we are going to, again, get rid of the ending and add the IDE, so that becomes nitride. So beryllium nitride. So that is how you name both, or how you come up with the name for binary ionic compounds as well as the chemical formula for bionic compounds. That's it then for this video. We'll see you in the next one.